Oh, g'day champions. We've got a bit of a Frankenstein here. We've got a Fender Super 6 Reverb chassis put in a reproduction twin cabinet. So this one got brought in for no power, which happens quite often on Fenders, and it just was the pilot light contacts were a little bit dirty. So I jiggled that around, cleaned it up a little bit, and it came to life. Brought it up slowly on the Variac, no massive runaways or anything. He was using it right up until the point where the light cut out, so we figured there's no harm in firing it up and having a quick listen. And it sounded okay-ish. The main thing is, it sounded like your brain was getting pulled out of your ears because the speakers are out of phase. So that will be a massive change. If he was happy with the sound with it before, I don't know how he could have been, but if he was, it will be mind-blowing once that's corrected. So the other issues I found was the reverb return is very noisy and oscillates at higher levels. So we'll have to inspect that. It could be a lead problem, it could be a connector problem, as well as the usual scratchy pots, that kind of thing. So we'll have a look and see what work's been done to it. I'd imagine that there's probably some work's been done to the head over the years, but we'll have a look and we'll go from there, come up with a few preventative maintenance plans and see what way the owner wants to go. Right, so she pretty much smashes the whole workbench, this one, so I'll get the chassis out and work on that in isolation, but in the meantime, just having a look at the front panel. In not too bad condition. Jack nuts and everything need a bit of a clean. The knobs need a bit of a clean, but there's not as much corrosion happening on this one as there was on the Princeton. So again, this has got the international voltage select, as is most of the amps out here, particularly the silver face ones. Doesn't appear to be any modifications of the rear panel. It's promising. The screws on the rear panels don't have any washers, and you can see they've already sunk into the Tilex quite a bit. They could pull all the way through pretty easily if over tightened, or what they do often, just like on melamine kitchen cabinets, that kind of thing, if you drive the screw in too far, the top skin sort of encloses around the screw and you go to remove it and it takes a whole big blistered layer off with it and rips the Tilex and everything. So I'll put some cup washers on there, just like Fender did. So I've got two Jensen C12Ks in there. First thing I'll do is make them in phase with each other, because it literally is one of the most unnerving sounds you've ever heard. Two speakers in a twin in opposite polarity to each other. It sounds like the amp's like inside your head. It's really weird and shit. That looks like a little laser cut logo down there. The Achilles logo. It's a bit nice, isn't it? On the baffle. Ooh, got a bit munchy down there. Drilling the hole for the caster pocket. The caster sleeve, whatever you want to call it, top hat, blah blah blah. So it appears to be made from flat sawn hoop pine, or possibly radiata, but that's just your typical hardware store planks. The vintage Fender stuff was all generally quarter sawn pine, or I think some were Douglas fir. I might be wrong there though. No, on Fender they probably just used whatever they could get their hands on. There's a nice little seared on logo, just like the ones I made. AchillesAmps.com, and then his mobile number if anyone wants to give him a ring. See what he's up to on a Friday night. Don't do that. As usual, we've got the really corroded, crappy molded plastic connectors that we should replace with some nice Switchcrafts, but I'll just check the continuity of the cable in the tank. 1.2 ohms, that's the coil, the drive coil. And about 160, well, about 170 ohms on the pickup coil, so that's about what we'd expect. I really just want to clean up all this wiring. Like, you shouldn't have speaker wires able to dangle out the back like that. Just looking at the speaker connectors, it looks like they've used those sort of auto connectors. Yeah, like the auto electrician things. They look probably crimped, but I'd like to hard solder them in place. There's no real need to have them removable, because you can remove it with the jack. So let's get this chassis out of the box. We'll piss the box off and we'll have a look at the guts and the state of it. Let's Let's hope it's not another hacked up nightmare, as all the silver faces seem to be. Sorry champions, I didn't have my lav mic on for the last couple of scenes. Now I've got to work left-handed. Geez, this video stuff's fun, isn't it? The things I go through for you, mob. Put that aside, get rid of the cab. Okie dokie. So a quick look at the chassis. She's in good nick. We've got a set of 4 Mesa branded 6L6s. That one, the getter appears to be, getter flash appears to be a little bit faded compared to the others, but that may be just manufacturing variants. It's not like white or anything, and there doesn't appear to be any massive overheating. The logos still look okay and stuff. Let's remove these valve shields and we'll see what's going on in the front end. Alright, V1. No markings. None that are legible anyway. V2. We've got a 7025 Sovtech. Sweet as, bro. V3. We've got a 12AT7 RCA. Sweet as. V4. 12AX7 Mallard. Pretty corroded pins. V5. Got a 7025 from RCA. Kind of bent pins and corroded. V6. Got a Sylvania 12AT7. Pretty much all the pins need a good clean. Now again, someone's been using some kind of grease. It looks exactly the same as the Princeton. It's not wax running from the inside of the thing, because it's really soft and it's like, feels like just like oil on your hands. So someone's on purposely applying stuff, so that makes me wonder if there's board conductivity issues once again, and this was some nuffy's way of trying to fix it. Anyway, moving on. So checking out the fuse. She's 3 amp. Now again, it says 3 amps low blow, but this being an international amp, that's for the lowest voltage. So when you're running on 250 volts, 240 volts, whatever the setting is the highest, you could pretty safely change that fuse to a 1.5 amp and have a little bit better safety margin there. So I'll just remove the 6L6s, check out the pins. It's sort of like this weird sandy, I don't know if it's corrosion or what on everything, but yeah, I'll have to give everything a good clean, just like every amp that comes in, which is part of the job. Looks like we tried to take that little pin contact with it, so we'll have to have a look, see if that's broken. Yeah, they're all Mesa branded 6L6 GCs with their silly color coding biasing setup. It's just made to pull money out of your wallet more than anything else. Got those annoying Bakelite sockets, but these are pretty well tensioned, so not the end of the world. So let's get this cap cover off and have a look, see if someone's had a go or if it's still original. Holy hell, mark this day. I've actually got a amp that's got the original caps, not some dodgy hacked up cap job. So you can generally rotate these cardboard sheaths around until you read the codes. So looking at these, we've got 30th week of 75, 30th week of 75, 75, 75, 75. And no real evidence of bulging or anything on the plug end, so that's kind of rare. Normally there's a couple of bubbles there happening. I'll discuss that if you want reliable long-term performance, and if you want it to sound like the classic recordings that you bought the amp for in the first place, we'll do a recap, and the customer agreed. We'll check the droppers for drift, and might look at replacing that wire. It looks like it's it's corroded, and that often works its way up inside the jacket for like a good inch or so, and makes it kind of unsolderable. So we'll clean all of that up, give the board a good clean. During the recap, probably completely depopulate it, and give her a clean and start again. So let's flip her over, we'll see what we're dealing with on the inside. Alright, so I'm pretty blown away by this one. It looks like no one's really messed with it. If anyone that's watched my channel, you'll understand my surprise here, because most of the stuff I've seen has been absolutely slaughtered by someone. So we'll check everything for drift. We'll clean up the wiring quite a bit. I mean, you see in their stock form here that the lead dress leaves quite a bit to be desired. Probably get rid of the hum balance pot, because they're known to fail quite often. And that'll clean up the wiring in this area, and we'll just add two fusible heater balance resistors instead. Check all the caps. These blue ones, despite some forum bullshit, these blue ones, I don't think I've ever seen one fail. They're really reliable. We'll check all the carbon comps for drift, particularly as usual the 100Ks there, the plate loads, because they're known to go high. And the screen grid resistors, which look original. Maybe not. The lines are a bit, the color coded lines are a little bit thinner, and you can actually see the molding mark, which you couldn't on the originals. The originals were sort of a lighter brown like that. Well, you can see these ones here. So I've got a feeling that they've been changed, but probably pretty early on in the amp's life. But anyway, we'll check them for drift. It looks like this switch has been rewired at some point. I don't know if it was replaced or what, but the Fender factory soldering goes through the hole in a little J and is soldered, and I don't think I've ever seen cable ties inside of a Fender amp. So something's been changed there. That wiring looks different. And common fault points, like down here, this resistor's known to crack its solder joint down there because there's no relief in it, and the board shrinks and expands and flexes. Looks like someone's reflowed a couple of the joints that cause that common kind of thing. Oh, there is one replaced plate load down there, so maybe one was out of tolerance or went open. So a couple of points that the board loves to leak at is, again, here between the phase inverter supply node and the grids, because it goes off to the grids of the 6L6s. So cleaning this area thoroughly is a good move. If that doesn't help you, then sometimes you have to rethink that area and get those grids off the board. Another spot is over here. You got the plate load there for V4, and then you've got a connection right there, a coupling cap right there, sorry, which goes off to one of the pots, so that can lead to a bit of scratchiness on the pot. Similar stuff here and over here. This reverb driver has the loop wire connected to the anodes. In some of them, the grid wire was the loop, and it causes a bit of a pickup loop. But this is how you want it wired. They had these caps all throughout just to tame oscillation, I believe. When you tidy up the lead dress, often you can remove them, and it gives a slight increase in the openness of the top end. So looking over here, we've got someone's put a new piece of coax in for the vibrato channel. That's still the stock coax there, coming from V2B, and that's still the stock just single wire coming from the normal input jacks. So it looks like someone's been tackling a bit of noise on this thing, as well as some leakage in the board. So pretty much par for the course. It's good. It's going to be a good amp to work on for once. These heater connections are scarily close. If they touch, there's going to be a bit of fireworks down there, so I have to separate them and maybe heat shrink one of them or something. Should be fine without it. I'm going to redo the bias supply, new caps, with new diodes too, because I have had these fail before. All the grounds will be removed off the transformer hardware, because if I undo these, and often they come in there like finger tight because the thing's been thrown around for 10 years, 20, 30, 40, 50 years, these just fall off. There's no actual bond between the solder and the chassis there. It's just relying on this nut. They slobber solder all over it, but it literally just comes straight off. You don't even need to heat it when you remove that bolt. You can see down there that solder joint's already cracked. If I pull this wire, it's probably just gonna, yeah, it's just coming up. So there's no bond there to the chassis at all. The solder's just for show, mate. And same goes for that center tap for the HT and the crown for the bias supply cap there as well. Now another little upgrade I like to do to these is changing the bias balance pot so it can adjust the overall bias level as well. And I do that with a trim pot on the back. So one of the I've never had to say the word out loud. 25Ks on the back there to change the overall bias feed. So you've got balance as well as overall bias. If it was your amp, or if you were cool with it, a probably easier way is to just have one pot per pair. Just drill another hole and mount them like that. But don't like drilling holes in old amps, because you never know what's going to be worth $1 million tomorrow. So just putting the bias trim pot on the back of that pot means you can remove it and clean it up and return it to stock configuration if you ever needed to in the future. Now again, same old story on these voltage selector switches. The phenolics gone, all buckled. You can actually see the movement of the elements inside the switch there when I turn them, and they do start to get intermittent. So I might also ask the customer if I can just bypass that and hardwire it to 240. So I noticed this version had 25 microfarad on the driver's stage for the vibrato, tremolo, whatever you want to call it. You know, it's interchangeable these days. If you change that to a 5 or a 4.7, it makes the speed knob a little bit more responsive. You've probably experienced in the past where you turn it and it cuts out for a minute when you turn it, and it takes a little while to start when you first press the button. Well, reducing the value of that bypass cap there reduces that almost down to nothing. So the old chassis is pretty grungy. We'll do the best we can to clean it up without having to remove everything, but primary objective is making sure all the grounds are reliable. Alright, so we'll check some of the resistors for drift. Slope resistor within tolerance, 108, 108, 102 there within tolerance, 10%ers. I'm just trying to work around the camera here. 99, sweet as. 99. 111, just out of tolerance. 109. 108. 1.49, that's sweet. It's supposed to be 1.5, 1.52. Should be 820 ohm. 828, sweet as. 470, that's 480. So when you're checking resistors for drift, anything that's just got an open end going to a valve pin, you can test straight away in circuit, because well, the only thing you've got there is a cap which doesn't show up on the ohm meter unless it's well, shorted, and nothing's attached to the pin. So as long as you've got no shorts over there, you should be measuring directly the resistor value. And there's 361 and it's supposed to be a 330. We've got 482 and it's supposed to be a 470, a little high, and a 363 which is supposed to be 330, so that's a bit high as well. So that's the tail in the long tail pair. The bottom end of the tail, 34, that should be 33. So we've got 51 instead of 47 there, and 50 instead of 47. That's the plate supplies for the phase inverter. So it's all about looking at the schematic and figuring out, thinking about what your meter sees when you put on the leads. I see a lot of other people measuring for drift, and they're measuring stuff that's got other stuff parallel in it, like the negative feedback loop or whatever, and they're panicking because it's not what they expect. But when you look at the schematic, they're measuring exactly what you should expect, which is the equivalent. It's what the meter sees, which is the meter can't. The meter doesn't know that you're trying to measure this component. It's just measuring everything that's attached to the probes, yeah? So you got to look at the schematic and figure out what else is attached to those probes, and does it matter. So for example, we're measuring that 820 ohm in the feedback loop, and we're panicking because it's 94.3, yeah? But where does it go to? It goes to the output transformer, doesn't it? And what you're actually measuring is this resistance here to ground. If you look at the schematic, 94.1. Oh, there's a little bit of road rage out there. That's always fun. Hearing someone yelling at someone. Just checking the screen grids. 474, 472, 180, 183. That's weird. The colour bands are right. There's no valve in there either. So that resistor is actually out of tolerance low, which is weird for a carbon comp. And 483. I would like to see non-carbon comps in this position because they do go high and drift, and generally a metal oxide 2 or 3 watt, something like that's all you need. Happy days. Just a quick check of the grid stoppers. Make sure nothing's gone open from a shorter valve or anything. 1.53, 1.55. Working around a meter and a camera is pretty fun. 1.6, that's a little bit high within tolerance though, and 1.6. Generally the grid stoppers will go full on open or massively high if something goes wrong and a valve takes them out, and people will often not realise, plug in the valves, and because the amp makes noise they think everything's sweet, whereas it's performing way out of spec. So there you have it, legends. Nothing too dramatic for once. It's really good to see an amp that's actually been treated with a bit of respect, and you can tell the owner cares about it because he went out of his way to get a custom cabinet made for it. So should be a rather enjoyable job as opposed to cleaning up someone's mess as usual. Oh, did I speak too soon? I think I spoke too soon. There's some blobs of solder down there. There's always something, eh? So as always, thanks for watching, champions. I'll see you on the next episode.